Hello guys, so we are going to continue a discussion with respect to NLP, and in this video we are going to discuss about average word to vec, a super important topic again, because just with the help of word to vec you'll not be able to solve the classification problem. You really need to perform something called as average word to vec. Let's take a simple example and I'll try to show you. Right now we'll just discuss with respect to theoretical intuition, but as we go ahead we'll be discussing about practical part also and how we can implement average word to vec also. So over here I have my text data, the foot is good and the output is 1, 0 and 1, and you can see all these are my documents. Now as you know that with the help of word to vec, what we do is that we take every word and we convert that into vectors. Let's say that I'm using a Google pre-trained model. Okay, I'm using a Google pre-trained word to vec model. Pre-trained word to vec model. Now in this Google pre-trained word to vec model, what I'm actually doing is that over here you can definitely see that. Okay, so if this is my sentence, the food is good, right? Now the will get converted into some vectors. Okay, and when I've already shown you that with respect to feature representation, we will be getting a vector of 300 dimensions. So let's say this is the vector of 300 dimensions. Okay, so the will get converted into 300 dimensions with respect to this. Okay, the will be there. Now coming to the next word, that is food, right? Food will also get converted into 300 dimensions. And that is what happens with respect to this word to vec, right? Every word that is present over here, like is, will also get formed in 300 dimensions, and here also all these words will get converted into vectors with respect to this many number of dimension. Okay, perfect. So till here I think you're superbly clear, because we have already discussed about all these things in our previous session. But now you need to understand one thing, is that when we have this kind of sentences, and if we are basically writing this many number of dimensions, basically this many number of vectors are there. Let's say this is my 300 dimension vector, which is basically getting converted for the food and this. In the real world scenario, I should be converting this entire sentence into a vectors, right? But here you can see I'm getting vectors for the also 300 vectors. For food I'm getting separately 300 vectors. For is I'm getting 300 vectors, and for good I'm getting 300 vectors, right? 300 dimension vectors. Now this is a problem. At the end of the day, for this entire sentence, let's say if I'm getting a 300 dimension for this entire sentence, let's say this is my sentence 1 or document 1. My main aim should be that I should be getting only one 300 dimension with respect to this, so that I can take this as an input and this will basically be my output, and I can basically train my model. Right, but here you can see that since we are applying word to vec, every word is basically getting converted into a separate 300 dimension vectors. So in order to solve this, what we do is that we take all these vectors, and we find the average of it. Once we find the average of it, then we try to write that particular vector over here for this entire sentence, and then this vector will be considered for this entire document or sentence. Similarly, the second vector also is there. We will go ahead and calculate the average of it and we'll write it over here. Similarly, like this, every vector will basically happen, right? For every vector, so all the word vectors, averaging is basically happening, and that is the reason we say average word to vec. Okay, and why this will work? Because see, at the end of the day, you'll be seeing that we just require the vectors for this entire sentence. And right now we have for every word a separate 300 dimension vectors. So if we are trying to take out the average of all this particular vector, and if we try to write down as one vector, and this will also be, the length will obviously be 300 itself, right? This will be 300 dimension itself. But now with respect to this particular vector, I will be having my output. I can pass it through my model and get trained with respect to this. So at the end of the day, what happens is that if I'm having a sentence like this, after applying average word to vec, I'm just going to get, let's say if I'm using the pre-trained model, I'm going to get a 300 dimension vectors, which will be all this particular average of all these particular vectors itself, and all this will be over here, and I will be getting my output variable, which is already over here. And similarly, this will happen for the second word set document, third document also. So average word2vec basically says that, okay, we are not doing anything. Whatever vectors is getting converted, I'm just trying to average out each and every vector with respect to that, right? So over here, let's say the is having 300 dimension vector, food is having 300 dimension vector, is having 300 dimension, good is having 300. For every line by line, all the vectors, I'm just averaging that out and I'm actually finding out a value. And why we are doing this? Because we really want only one specific set of vectors for the entire sentence, right? So this is what average word2vec is basically. And for any text classification, we basically needed to solve through this specific way only. Now in the upcoming tutorials, what I'm actually going to show is that I'm going to basically use a library which is called as gensim. Okay. And there is also a library separately which is called as glove. But if you probably understand gensim, you'll be able to do everything. So first of all, we will go ahead and we will see with respect to a pre-trained Google word2vec. And then in the second instance, what we are going to do is that we are going to train a word2vec from scratch. That basically means we'll take a data set and we'll try to train a word2vec model. And again, with the help of gensim library, we'll be doing it. So I hope you got an idea about average word2vec. At the end of the day, why we are doing this, because for the entire sentence, we want some vectors. And since we are combining all this particular word, that semantic information will also be maintained, right? Hello guys, so we are going to continue a discussion with respect to natural language processing. In this video, we are going to solve the spam ham classification project using word2vec and average word2vec. I'll just change the spelling. Okay, so this will be an important one, guys, because with this, the accuracy level will be quite good, you know, but the main thing is that how we can train this entire project from scratch using word2vec. That is what we are going to see. And for this, we are going to use gensim as the library. So again, you know that how to install this. So you just need to write pip install gensim if you don't have already. Then I'm going to import two things from gensim.models, import word2vec keyed vectors. And I already have shown you that how you can load word2vec Google News 300 model. That is a word2vec model, which is a pre-trained model. And here I've already shown you that by default, you know, this particular word2vec model will give you vectors with respect to that. If I probably see the shape, it will be giving you a 300 dimension vectors. So if I probably want to see the vector, the king vectors itself, this specific word vector, these are the vectors that I'm actually getting. But now our plan is to take this entire data set, which is all the sentences, and then probably create a word2vec from scratch. So this will be an amazing one. And probably with the help of this, you'll be able to do a lot of tasks as such. Okay. And in this, we are again going to use different techniques. So let me just go ahead and let me do one by one. So first of all, this time what I'm actually doing, I'm also going to make some changes. In NLTK, I will not apply Porter stemmer, but I'll apply lematizer. Okay. So just this simple change, because I really want to give you the different types in a specific project, how you can solve the similar things. So I'm just going to import the word net lematizer, and then I'm going to basically say lematizer, okay, is equal to word net lematizer. So I'm going to initialize this with the word net lematizer itself. Now the next thing is that all the things will be same over here. You'll be able to see that I am basically removing all the special characters from the messages itself, right? And this is basically my messages itself, right? Then I'm lowering it, I'm splitting it, you know. And let me do one thing. I just don't want this all things to happen, you know. I don't even want the stop words to apply, because I want to see that how for each and every word this vectors will get created. Okay, that basically means I'm taking every word in this review and I'm just applying the lemmatization and I'm appending that in the corpus. This is the change that I'm doing. I'm not removing every stop word, because I also need to check that how it is basically creating a vectors for each and every simple words. Okay, so this is what I have actually done over here, and right now I'm getting an error. Okay, I think I did not import RE, no problem. So I'm going to import regular expression, and what all things I need to import if I go over here and see. Okay, NLTK, and import NLTK, and I also have to make sure that I download all the stop words, right? And now if I probably go ahead and execute it, so this is my entire corpus. Perfect. So the corpus is over here. right? So this is the corpus, and in this particular corpus, I have basically applied word-led lemmatizer. Okay. Now, there are also multiple ways how you can also do this. Every time you don't have to probably do this. Today, I'm going to show you some more. In this particular video, I'm going to show you some more techniques. Let's say that I want to create all the words. So this is basically my words. And I'm going to show you a special function which is called as simple underscore processes. Okay. And for that, I just want to import two more things. Let me just import it. So two more things I'm going to import over here. One is sent underscore tokenize. You know what is sent underscore tokenize. And this is a super important one, which is nothing but from gensim.util. I'm going to import this simple underscore process. Now, probably if I show you the definition of simple underscore process, here you will be getting an idea about what simple underscore process will basically do. If I press shift tab, it converts a document into a list of lowercase tokens, ignoring tokens that are too short or too long. So if you also want to make sure that you want to lower any kind of tokens, you can directly use this simple process. And I'll just show you one way where I'll have all the words and all the things. So I'll say for sentences in corpus, because in the corpus, I'll have a list of sentences, right? I will just write sent underscore token. I'll first of all create all the tokens itself with respect to sentences. And I'll write sent underscore tokenize. Okay, with respect to all the sentences. So this sentence may have 4 to 5 sentences. It can also be a paragraph. Each and everything, it can be different. And then I will say from sent in sent underscore token, right? And I'm just going to apply this. I'm just going to apply this simple process. Okay, on all the sentences. Now see what will be the output. This is super important. Okay, first of all, let me just write down the code so that you'll be able to see the output. And this I'm basically going to append in my words list, right? So this is what I have done. Okay, now if I probably execute it, now see what will be the output. Initially I had the corpus. Corpus is something like this. Now if I probably go and see my words, so this is, see, for every sentences, I'm getting all the list of words. So this is my sentence 1, this is my sentence 2, this is my sentence 3, right? And this is my sentence 4. So like this, I can get each and every sentences. That is what I'm actually meaning. Okay. So over here, you'll be able to see with respect to every sentences, I'm getting all separate words. And this lowering process is also done by the simple underscore process, which is very good. So every time you probably don't have to do this. You can also take this specific path. And again, there are various ways. I'm just using the most efficient way, most easy way, so that you will be able to follow the same thing. Okay. So this is with respect to all the words that I have probably got. You can explore this with respect to all the sentences, all the words I'm able to get, which is very, very good. Now is a super important thing. Because see, at the end of the day, I need to train all this particular word with the help of Word2vec. And then with the help of AvgWord2vec, I'm just going to do the concatenation, which is super, super important. So let me go ahead and let me show you that now how you can basically train everything from scratch. And again, you know that what is the sentence size, you know what are the different things in this, right? Perfect. You have got all the sentences with respect to all the words. Okay. Now the next step that I am probably going to do is that I'm going to import gensim. Okay. And now let's train this model. Let's train this Word2vec model from scratch. Let's train Word2vec from scratch. Like how that Google has basically trained, right? With the help of gensim only, we'll try to do it. Now over here, I'm going to import gensim.models.Word2vec. And here, just let's press shift tab. Now over here, gensim.models.Word2vec, here you'll be able to see that the first parameter that I'm giving is sentences. Now already I have my sentences, that is basically my words. Okay. Now coming to the other parameters, which are the important parameters. Here you can see vector size. Now this is what I'm saying. Now Google Word2vec, which we have seen in the pre-trained model, it is giving you 300 dimensions. But here you can see that you can set your own dimensions. You can set 100, 200, 300. So I'm going to by default set vector underscore size is equal to 100. And you can play with all the other parameters like minimum count. Minimum count is basically like, if you probably see this, right? Somewhere this entire information is given over here. But here I'm just going to focus on very important features. But definitely you can try and you can see all the features, what it is basically doing. Right? See what is minimum underscore count. It ignores all the word with total frequency lower than this. This is basically to create the vocabulary size itself. So over here, what I'm actually going to do, I'm going to give my words. Along with that, let me keep this vector size as 100 because I really need to get every words will get converted into 100 dimension. I'll keep the windows and minimum count as the same size. Okay, so let me just go ahead and probably execute this, and probably I will just store this entirely in the model variable, and this will be my model itself. Right now, if I go ahead and basically write model dot wv, that is word to vector, and there is something called as index underscore dot to underscore key, and this particular line of code is to get all the vocabulary. Okay, so if I probably execute now, here you can basically see these are all the vocabularies over here. If you really want to check what is the vocabulary size over here, so you can basically write model dot corpus count. Let's see, corpus count, and if I execute it here, you can see 5569 is basically my vocabulary size, and you can also see that for how many epochs it has basically been trained, and by default it will be taking 5 epochs. The more number of epochs, the more better it is, but just to give you an idea about how the training will happen, because if you give 100 epochs, probably this entire training will take a good amount of time with respect to that. Right now I've just done it for 5 epochs because that is what is the default value that is given over there. You can keep it to 10, 20, whatever values you want, right? And now if I probably try to see similar by word, so there is a function called as similar by word. Let's say if I'm taking a feature called as skid, right? And if I execute it, now here you can see with respect to this skid, what all values you are able to get, or what all similar words you are able to get along with the cosine similarity score, right? This is very, very good. Suppose if I say good, right? So here also you can see morning, what, not, happy. See, happy is also coming. I know the training has just been done for 5 epochs, so you are probably being able to get like this, but here you will be able to see that yes, you are able to get some of the words which are super similar, right? Now, one more very important thing is that whatever vector, see, what is the vector that is getting created over here? So if I write model.wv of good, right? And if I see this vector size, you'll be able to see it is 100 itself, right? So these are the 100 dimension that is getting created. So probably if I write dot shape, you'll be able to get this. So I'm getting 100 different vectors with respect to every word that is good. Okay. Now this is a super important step. As I said, why do we use AvgWord2vec? I've told you that, see, let's say, or let me just go and show you. Okay. This is my words, right? Suppose if I say words of 0, this is my first sentence, go until Jurong point this. Now, if I probably consider this word2vec, for every word, it will give you 100 dimensions, right? For every word, for go, it will be 100 dimension vectors. For until, it will be 100 dimension vectors. For all these things, it will be 100 dimension vector. But what we really need to do is that for every one sentence, we need to get 100 dimension vectors, right? That is what we really need to get it, right? In order to train our model. So for what we can do is that for go, for until, for Jurong, what we can do, we can basically do the averaging of all the vectors of with this specific word. And then we will only be able to get the 100 dimensions. So let me just explain you what I'm actually trying to say, right? So over here, you'll be able to see that. Let me enable the writing over here so that you'll be able to see. So what I'm actually saying is that, suppose, let's say, let me first of all rub this, and this is super important because without this, the average word2vec you'll not be able to train. So let's say I have this go word, I have this until word, I have this Jurong word, and I have a lot of words like this, right, in the sentences. So go will have a separate vector like this, until will have a separate vector like this, Jurong will have a separate vector like this, and every word will have a separate vector like this, right? Now, this is my entire sentence, and for this entire sentence, I want a vector of 100 size. So what I will do, I will average up all these numbers. Let's say I'm going to average up all these values, and I'm going to get one specific vector. So this will be for my entire sentence. And this particular vector size will also be of 300 dimensions. And that is what I've already told you about how the average word2vec intuition is all about. Then this sentence will be treated as this input, and the output, whatever output is there with respect to that, either it is 1 and 0s will be taking that. So this is what we basically do in average word2vec. So in short, I have to find out the average of all this. Okay. And that is what I'll show you in the code itself, right? So here I've actually created a function which is called as average word2vec. Here I'm saying that model, see, return np.mean. Mean basically means average. For word in doc, for every word in doc over here that I have given, if the word is not in this index.to key, then only I will probably try to create my model vector, right? And then this will basically happen on axis is equal to 0. So this is a very simple function. I'm just making sure that row wise I have to probably do the mean. That is only what we are doing over here. So let me just execute this, okay? And before I go ahead and probably do the other work over here itself, I also want to make sure that I install one progression tab, right? So to understand the progress, so I'll be using tqdm, okay? And this will probably take some time with respect to this because this tqdm and why I'm doing this, I'll just tell you in some time, okay? So from tqdm, I'm going to import tqdm, okay? And here it is. So here what we are going to do is that I'm just going to import this, just a second. Okay, now this is done. Now what I'm actually going to do, I'm applying this entire thing. I'm trying to apply this word2vec on every sentences, on every sentences. Okay, this is super important. I will try to apply the word2vec on every sentences, average word2vec. So whatever things I'm basically doing this for every sentence, it will take up and it will apply this particular thing and it will do the average of all the vectors. Okay, and that is what we are doing over here. Just to see the progress, I've written hello, but I think that is also not required since we have the tqdm. So I'm just going to remove this and just go ahead and execute it. So here I see some error. Okay, numpy is not there because I did not import it. Not a problem. So I'll say import numpy as np and we'll start the process. Now here you can see that I think we did not get any kind of errors. And now let's go and see our x. Okay, so this is what I am able to get. See how quickly it has happened. So this is with respect to the first sentence vector. This is my second sentence vector, which is quite amazing. And this is my third sentence vector. And here we have just done average word2vec, right? Amazing, right? So this is what I'm actually getting. And if I probably try to see my x.shape, you'll be able to see x.shape x. Okay, x is a list, not a problem. So if I probably go and see length of x, you'll be seeing that this will basically be my 5569, which is the input size of the messages, right? So this is what is my input size of the messages with respect to that. And this is how we have basically done the entire word2vec, which is quite good. Now the next thing that we just need to do is that try to convert this into an array. So here I will just write x_new is equal to np.array on x, right? So this becomes my independent features, right? So this is what I'm doing. But here you just try to understand what we have done. We have just done average word2vec on every sentences after finding out the vector, right? And this, you can see how quickly it has happened for all the sentences over here. And this is my final sentence over here, right? All the vectors. This is the vectors 100. And remember, all these are 100 dimension. So if I probably now see this x.shape, see if I write x_new dot shape, you'll be able to see I'm having 5569, right? This is super amazing. And this is what we have actually done it. So let's say if I'm writing x_new of 0, I'm actually getting my first array, right? Which is very good, right? And now if I probably try to see the shape of this, you'll be able to see that I'm getting 100 dimension, right? So super cool. We have done an amazing work with respect to this. And obviously, you know what is my dependent feature is. So dependent feature is my output feature. Okay, so I'm just going to write my dependent feature over here. So already I've shown you in the previous, like how you can take the dependent feature. I will apply this as my output feature over here and take the first label right over here. And that is done. So this is my Y dependent output feature and this is my independent feature. Now in the upcoming video, what we are going to do is that we're just going to apply the machine learning algorithm, because I have now my input features and this is my output feature. All I have to do is that train my model. Right? Hello guys, so we are going to continue the discussion with respect to the spam ham project with the help of word2vec and average word2vec. Already we have converted everything into the vectors, and we also saw that our x_new, that is the data, right? It is basically having 5569 rows. Now there are multiple things which I really want to talk about right now, and this will probably be giving you a sense like what is necessary before we start providing this entire data set to the training algorithm, right? Now, first of all, here you can see that whenever I see with respect to any sentences, there will be 100 dimension. This is perfectly fine. But if I probably see the shape of the messages, so if I see the messages right now, this is what is my messages, right? And probably if I see the shape of it, here you'll be able to see 5572 rows and 2 columns, right? But the number of rows that is coming in x underscore new, it is 5561. 5569. So obviously there is a problem because initially we had 5572 rows. Now we just have 5569 rows, right? So this is not matching, and x underscore new is after all the sentences are converted into vectors with the help of AvgWord2vec. So one important thing is that we have to make, and probably if I also see the y value, right? So y shape is also, if I just go ahead and execute this, now here you can basically see with respect to this, let's say I'm going to basically use messages of level, right? So if I also see y shape, that is the output feature, is also 5572, but my independent feature is 5569 rows. So this is a big issue. That basically means our training data set is just having 5569 data points, but my output data is 5572. So after pre-processing, right, we have lost 3 records. Now we really need to find out why these 3 records have been lost. And this is an amazing use case, guys, because when I was also solving this problem, it took me a lot of time to understand where that 3 rows went. And how did this 3 rows get removed from this particular data set? That is also a thing. Now let me go back up over here, right, before the corpus. So here was the corpus. Let me show you the corpus. So here I was getting my corpus, right, after this code. Now I have added one line of code. I'm saying that I, j, k, 3 information I'm taking it out, and I will be nothing but I'm zipping it length, corpus. So I'm basically going to have one information about the length of the corpus. So it'll be in this mapping condition. And then I have this corpus, and then I'm displaying the messages. Okay. And I'm only displaying when if I is less than 1. Now what is I? I is nothing but this is the length of the corpus, right? If the corpus length is less than 1, I am basically displaying all the data, right? So once I execute this, and probably you can see this is a very simple Python code. I'm used zip list of map length, corpus, then I'm getting the corpus value, and then I'm getting the message value, right? And over here you can see that initially there was some message like 645, and it has got removed and it has become blank. Why? Because I have told that only A to Z and capital A to Z should be there and everything should be removed. I could have also put up like 1 to 9 also, then also it would work, right? But now in this particular scenario, it is just going to remove everything, even words, even this kind of characters, right? So everything is getting removed and it is becoming blank. So that is the reason I'm getting 0. And if I probably execute this, how many values I'm getting? I'm getting 3, right? 1, 2, 3. And this is like, if I probably subtract from my entire data set, then I am like, initially my data set was 5572. If I'm subtracting 3, I will definitely get 5569, right? So that is the reason why 3 is missing. Now we need to find out with respect to y also where that length is less than 1. So what I've done is that over here, when I'm creating y, I've just written this messages of list of map of lambda, length of x is greater than 0, corpus. When I've written this, I just have to replace this messages with y, and now you'll be able to see that I'll be getting the y dot shape as same. Nothing I've done. I've just found out that which all length of the data or the paragraph or the sentence is greater than 0 in this specific corpus. I'm just taking that particular messages and probably doing get underscore dummies, and I'm getting my output feature, right? Now one other thing. Now first issue is basically solved, right? Now even though my message is 5572, now my x underscore new is 5569, and if I probably just see x underscore new, let's see x underscore new. So x underscore new is basically, so if I execute this once again, let me just execute it. Okay. Or forget about x underscore new because I have converted x into x underscore new. So here it is got converted, and this is my max, and this is my x underscore new. Now, if I probably consider x also, forget about x underscore new. Let's see x. Okay, x is list of arrays. Okay, list of arrays. Now, if I probably see the length of x right now, it is the type is, what is the type of x? It is nothing but list. The length of list is 5569. And if I probably write x of 0, so this will be my first sentence vector. Then if I write x of 1, this will be my second sentence vector. Similarly, if I write x of 2, this will be my third sentence vector. Okay, so all these things are there. Okay, now this is perfectly there. Okay, now what we are basically going to do is that, now see, this is super important. I need to add each and every vector that are present over here as a row in a data frame, because it will become my independent features, right? So for that, what I'm doing is that, again, I'm repeating it, guys. See, x of 0 is basically my vector of the first row, right? First sentence. So I need to add all this particular thing inside a data frame within the first row itself, right? Because these are all the dimensions. Similarly, x of 1 should be added as my second data point in the data frame. And for that, I'm writing this specific code. My y variable is already ready. What I've done is that this is my final independent feature. I've created pd.dataFrame, and then I'm writing for I in range of 0, length of x. Okay. And then I write df.append pd.dataFrame of x of I dot reshape of 1, -1. Now this is super important. Understand this. Okay. So if I say x of 0, okay, and if I probably just see the shape, this is a single dimension array, right? 100, because it has 100 vectors. Now what I need to do is that I need to add this as a row in the data frame. So I will be using reshape, and here once I write 1, -1, here I'll be able to see that this entire row will now have a dimension of dot shape, like 1 row and 100 columns. And that is what we really need to do, right? The first sentence is nothing but it should be a 1 row data point with 100 different vectors. That is nothing but 100 columns. Now, similarly, what I'm actually going to do, I'm going to add like this for every data points that is present inside x of I, right? Basically the x value. Suppose if I want to do it for x1, x2, x3, all this data point needs to be appended over here. So that is the reason why I have written for loop. And I'm writing this, and I've used ignore underscore index is equal to true. So one assignment, just try to find out what is the meaning of this. And it is very simple. You just go ahead, press shift tab, you'll be getting the information over here itself. Okay. So once I execute this, now you'll be able to see that this execution will take some time. Now, if I write df.shape, now here you can see that 5569 data points is there. And now we have 100 dimensions, 100 features, right? And that is what it is there. Now, if I probably go ahead and write df.head, you will be able to see these are all my data points. I don't worry about what is the columns. So this is my first sentence data points. This is my second sentence data points, right? And these all are my independent features, and it is all 100 dimension, right? Now what I can do is that I can basically write my independent feature is nothing but x is equal to df, right? So I can basically write like this, and my y already I know, I'll just print the y also. Okay, so this is my x and this is my y. The next step, what I will do, again, it's very simple. I will do the train test split. So train test split, and here I'll be giving my x, y, this is there, and automatically everything will start getting executed. So this is my x train dot head, right? And here you can basically see all my data set with respect to this. What is my y underscore train? That also you can basically see. And let me write dot head. So I think in a series dot head will not work. Okay, it is a numpy array, not a problem. So this is my y train, right? So everything is there. We have our independent feature, we have our dependent feature. Now we can apply any machine learning algorithm. For this case, let me just say, because at the end of the day, these all vectors are a dense vector. So I'm going to basically apply sklearn random forest. Okay. And it should be a classification problem. It should be a classification problem. So here you can see from sklearn.ensemble. Okay. From sklearn.ensemble, I'm going to import random forest classifier. Okay, so this will be my classifier, and I will just initialize it to random forest classifier, and this is done. And after that, I will just write classifier dot fit on my X train, Y train. Okay, now I'm getting an error. Let's see what is the error. Input contains nan infinity or a value too large for data type. Now this is the error that we are specifically getting. So let's see how we can actually fix this. So guys, now here you can see that I am getting a specific error over here, right? It is saying that input contains nan infinity and all. So we did not do a check. So that is the reason we are getting this. So once I get my X value, let's see that whether I have any nan values or not. So here if I write X dot is null, okay, dot sum. And if I probably see this, how many null values that I have, okay. Function has no attribute sum. Okay, not a problem. Is null dot sum. So here you can basically see that, okay, there are 12 null values in every feature, right? Every columns in short, right? So obviously we have done so much in for pre-processing and all. So we can directly remove this vector. So before that, what I'm actually going to do is that I'm just going to make sure that I have my output feature also over here and append it to this. So I can basically do it in my df itself. So I'm just going to make a cell up and let me write df of output. Okay. First I will initialize it to y value. So this is done. So this is my entire df dot head. Now here you can see I'm just adding my y variable also over here, and finally you'll be able to see this is my output. Okay. Now first thing first, I will just remove the null value. So I'll say df dot, how to remove the null value, fill or I can say drop na. Okay, drop na, and over here I have features like axis is equal to 0, axis is equal to 1. So I would definitely like with axis is equal to 0 because I want to remove all the rows itself. And let me make sure that, let me just write it as in place is equal to true. So this is got executed. Now if I probably go ahead and see df dot is null dot sum, now I think we are fixing all the problems. Again, is null is there. So dot sum, now I have zeros. Now all I have to do is that put over here, right, as df. And again, if I probably see this is null, okay, in my x value. In my y value, I can basically use df of output. Okay, and this will be there. Let me see what is the output variable. Yeah, capital O. Okay, so this will basically be my output feature. Done. So I have my x and y. Now all I have to do the train test split, then again head, and this is my y train. Okay, and then I'll apply my random forest classifier. Again, I don't need to check this, and let's go ahead and do the fit. Finally, the fit has been successfully done. Now you just understand that just to do this, you know, how many different issues are coming, and I'm deliberately not deleting all these issues. I'm trying to show you what all situations, what all different things may come. And then what I can do is that I can just do the prediction. So here I'm just writing classifier dot predict, and this will basically be my text test data, and this will basically be my y pred. Okay. And again, on random forest classifier also, you can perform a lot of hyperparameter tuning. Now let me just go ahead and write the accuracy score and classification report. So here I'm going to print accuracy score with respect to y underscore test, comma y underscore pred. So this is the accuracy that I'm getting, which is good. Okay. And similarly, I can print my classification report with y underscore test just to make sure that everything is fine. So here also I'm getting a good accuracy, and sometimes this can also lead to overfitting, but I don't want, if you don't want to do overfitting, you just need to perform some hyperparameter tuning in random forest. So I hope you got an idea about how we can perform this, and finally we have done this in an amazing way. Line by line, we have written so many codes, we have understood different things. You just need to practice things and you will be able to do this. So with the help of AvgWord2vec also, we are able to do this, right? And yes, finally we are done. All now you have to do is practice with different problem statements. There are a lot of data sets, take up, do it, and yes, try to do it in a better way, right? So from this also, I'm just going to remove this 2 lines of code because I don't want you to get stuck over here. Just to explain you, I have explained, I have just put up this. You need not execute this line of code itself. So yes, this was it from my side. I will see you all in the next video. Thank you.